So, what is Solidworks? Well, this may seem like an obvious question. It's a CAD tool, right? Besides being a very user-friendly CAD tool, I'd like to tell you a little more about how it behaves before jumping right in. Solidworks is a parametric, feature-based system that allows you to create 3D parts, assemblies, and 2D drawings. Parametric modelers behave differently than other more primitive CAD tools that are object-driven. What I mean is, in a parametric modeler, everything is controlled by either parameters, dimensions, or relationships. For example, if you want to move the position of a black hole that's in a block, in a parametric system, you would change the dimension or relation that controls its position. In an object-driven CAD tool, in order to move the hole, you would move the hole as an object, and the dimension would update. Now, while both systems do get the same task accomplished, eventually, there is much more power and flexibility when using the parametric system. The parameters and relationships you set up allow you to have control as a designer over something called design intent. The term design intent basically describes the way your design will behave as you make changes to it. By using parameters and relationships, this gives you ultimate control over the model. Here, in this example, I need to center this circle within this rectangle. I know the rectangle is 4 inches by 6 inches. One way to center the circle is to dimension it 2 inches from one edge and 3 inches from the other edge. That centers the circle on this rectangle, but does this capture my design intent? Well, let's see what happens when I change the size of the rectangle to 7 inches by 8 inches. As you can see, the circle is no longer centered, so no, this dimensioning scheme does not capture my design intent. So how can I center this hole so that no matter what size the rectangle is, the circle will always be centered? First, let's get rid of these dimensions. The way to capture my design intent is to use a geometric relation instead. I'll sketch a diagonal line using this center line tool. Then I'll add a midpoint relation between the diagonal line and the center of the circle. Now, no matter what the size of the rectangle, the circle will always be centered. This is just one example of the countless ways to capture your design intent when modeling in 3D. Some simple examples of incorporating design intent using features would be choosing a through-wall end condition for a hole that must always go through the thickness of a part. Perhaps a keyhole slot. Or perhaps choosing an up-to-surface extrusion end condition to keep two surfaces at the same level. So you can see how modeling in a parametric environment can be very powerful. The other huge advantage of this type of system is that you also get associativity between your parts, assemblies, and drawings. Meaning, if you make a change to the design of a part, the change will take effect in any assemblies that it's a part of, and its 2D drawing will update automatically as well. You can also make the same design change from the 2D drawing and the part will update, as well as the assembly. This associative behavior saves you lots of time when you make design changes, so that you only have to make the change once, and all associated items will automatically update appropriately.